long is that? If you want to do the Pythagorean theorem on this triangle right here, this is 5, this is 6, you wind up with what? The square root of 61 should be about 7.8 according to my mathematics. Let me come up here now and let me do this with the ruler. 7.8. Look, here's 7.8 right there. Is it on? It sure looks on to me. Why does this happen? Why does mathematics control physical space? Or let me say it a different way. Why does the physical world obey mathematics? That's wonderful. What's going on? You guys should read some Galileo or some Pascal or even some of the ancient mathematician Ptolemy. We discuss why that is. But it's wonderful. And it's wonderful, I think, that human beings can discover and use this connection between mathematics and the physical world. All right, now it's time to get serious with some problem solving stuff. That was fun. Let's now go over to some notes and some problem solving. Okay, so the Pythagorean theorem, as we've seen, is what you get when you join two squares at a right angle in their corners, and then the area of the one is equal to the sum of the areas of the other two. So if I come in here, here's my figure, that's got to be a right angle, all right? And then I get c squared, the area of the big square is equal to a squared plus b squared. All right. And the triangle that we're talking about usually when you see it, that's actually the hole that's in the middle, right? And it works exactly. It's got a geometrical proof to it. So let's do a little bit of review here now. A right-angled triangle is a triangle which has a right angle as one of its angles. The side opposite the right angle is called the hypotenuse and the longest side of the triangle. And the other two sides are called the legs of the triangle. So now the way I want you to think about it when you do a right triangle problem is I want you to first, your eye needs to find the right angle. And you see a right angle, we're told it's a right angle because of that little square in the corner, right? Your eye needs to find that. Then the side that's opposite it is the hypotenuse. It's never one of the other two sides. The other two sides are called legs. Now, only right triangles have a hypotenuse. So I would change this. The hypotenuse is the longest side of this. Not any triangle, only a right triangle, only this triangle. If it's not a right triangle, it doesn't have a hypotenuse. I've seen students try to use the Pythagorean theorem on all kinds of triangles. So they'll have a triangle that looks like this, a big obtuse triangle. And they'll try to say, oh, this is A, and this is B, and this is C, and so C squared is equal to A squared plus B squared. No, that's not a hypotenuse. What's the longest side of the triangle? Yeah, lots of triangles have longest sides, but only a right triangle has a hypotenuse, and it is the longest side of a right triangle. But the longest side is not the definition of a hypotenuse. It's the side opposite the right angle. All right, so enough of that. Now, let's talk about how to do these with problem solving. So if I've got a right triangle here, how do I know that? I see the mark right there. I'm told it's certainly a right triangle. I need to find the missing side, all right? So my eye goes to the right angle. My eye then goes, or my mind goes to find the opposite side, and I write the formula down. C squared is equal to A squared plus B squared. You might have done it A squared plus B squared is equal to C squared. I'd like you to switch it. I'd like you to start with the hypotenuse first, because the hypotenuse is the most important part of the right triangle. So your mind needs to find that first. All right. Now I set it up by replacing the values in the formula with the things that I've got in the triangle. So I've got x squared. That has to be equal to 4 squared plus 7 squared. Doesn't matter what order you put the A and the B in. And so then I get x squared is equal to, what's that, 16 plus 49. And I get then in the end x squared is equal to 65. And then I solve this by square rooting both sides, so I get x is equal to the square root of 65, not plus or minus, because the x here in this case means a distance, and the distance can't be negative. So algebraically, you'd get plus or minus. But when we're talking distances here, which means it's controlling real space, you don't have a negative one. So the exact answer would be the square root of 65, or if you're going to do an approximation, x is approximately equal to, I get 8.0623. Nice. How about one like this? Well, again, find the right angle. Look, there it is. Find the hypotenuse. Look, there it is. Lots of students will set this up wrong. They'll set it up by saying x squared is equal to something, 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 because they want to solve for x. And they should solve for x, but you can't just set it up for the variable to be equal to whatever you get when you add the other two things together. Find the hypotenuse. The hypotenuse is not x, it's 11. Okay, so c squared is equal to a squared plus b squared. Where's c? Where's the hypotenuse? It's that one. It's 11 squared is equal to 6 squared plus x squared. Some of you are a little irritated at me because I'm putting parentheses around all the parts, and you're like, what are you doing that for? Trust me, you'll need it. You don't necessarily need it here, but you will later. It's a very good habit to get into. And if you don't do it when you need it, you'll get it wrong. So what have I got now on this one? I've got 121 is equal to 36 plus x squared. I do the math. I get x is equal to, say, the square root of 85. Or x is approximately equal to 9.2195. 9.2195. Let me think about this. Can this side be 9.2195? Well, it has to be shorter than the hypotenuse, because the hypotenuse is the longest side in any right triangle. Is it shorter than that? Yes. So it's reasonable. If you'd have gotten a bigger answer than 11, like 14 or something like that, you would have made a mistake somewhere. Several people would not square root both sides, so they would say x is equal to 85, which is impossible. How can one of the legs be much, much longer than the hypotenuse? Can't be. All right. How about this one? Find the right angle. There it is. Find the hypotenuse. There it is. Set it up. Use parentheses. C squared is equal to a squared plus b squared. Replace the c with what it is. What is it? 2x with parentheses squared is equal to 9 squared plus x squared. So if I simplify, this becomes 4x squared. Do you see now why I needed the parentheses? It's the entire group. The base is 2x, not just x. 4x squared is equal to 81 plus x squared. Subtract x squared. I get 3x squared is equal to 81. X squared is equal to 27. X then is equal to the square root of 27, which is 3 root 3. Or approximately 5.1962. Is that agreeable? Well, that would make this about 5, and that would make this about 10. Yeah, that makes sense, because the hypotenuse then has to be larger than 9. Okay? See how this is working out? Use parentheses. They're your friends. Oh no, now this one. Okay, find the right angle. Whoop, there it is. Find the hypotenuse. Right there. All right, same thing. C squared is equal to a squared plus b squared. Every time you use the formula, write the formula down. Now substitute. 13 squared is equal to, oh, now we got a binomial. X minus 2 squared plus 5 squared. Now simplify. Okay, so that's going to be 169 is equal to x squared minus 4. Is that what you said? Nope, you can't square just the pieces. You got to FOIL it out. It's x squared minus 4x minus 4 plus 25. And now I set the left-hand side equal to 0. 0 is equal to x squared minus 4x minus 140. You can solve it by the quadratic formula. You can solve it actually by factoring. Or actually right here at this point, you could have left this as a square pass that to the other side by subtraction and then square rooted both sides. But in any case, in the end, you should get x is equal to 14. Okay? Now, what about that one? Well, if a right triangle means that the Pythagorean theorem is true, if the Pythagorean theorem is true, then the triangle is a right triangle. So let's work this process backward. Is this triangle a right triangle? You're going to look at the picture and go, oh no, it doesn't look that way to me. But again, mathematics is not about how it looks to me. Mathematics is about certainty, right? So I can't just go by how the picture looks according to how it's drawn. I have to go with what I know for certain. Well, what I know for certain is the side lengths. Well, let's see if the side lengths satisfy the Pythagorean theorem. Well, what would be the hypotenuse then? Well, it has to be the longest of the sides. So that right there, 17, has to be your hypotenuse. So let's double check it. Let me just see here. C squared has to be equal to a squared plus b squared if it's a right triangle. And so that means 17 squared, is it? I don't know, I'm asking. See the question mark on top? I don't know. Is it equal to the one short side, 15 squared, plus 8 squared? I don't know. Let me run the numbers. You get your calculator and have to run your own numbers. So I'm getting 289 is equal to maybe 225 plus 64. And if I do that mathematics, 289 actually is 225 plus 64. This is 289 over here. So is it a right triangle? Yes, it is. How do you know that? It satisfies the Pythagorean theorem. You can't just go by how it looks. You gotta do what you know for certain. Okay, now this is going to be interesting. What length of the longest toothpick which can be placed inside a rectangular box that's 3 by 5 by 8? Don't tell me 8. You're going to say, why not? That's the longest side. Yeah, but that's not the longest length available. When we do a box, well, let me draw a box here. You draw a box by taking two rectangles and drawing them one offset from another one, like that. And then you connect the corners, here to here, here to here, here to here, and then here to here. And then maybe let me shade the outside so that you can tell maybe if you're looking to the inside of a box. Yeah, it's a pretty good box. When you do a box, the length is always the longest side on the base. The width is always the middle number, and then the height is always the smaller of those numbers. If it can be arranged in any way. Now they may tell you like the open top box is different, but anyway, this is the most stable arrangement of a box. It won't tip over this way. You put it with any other base side as its bottom, besides the two longest ones, and you can tip it over. Right, this has got the lowest potential energy, but anyway, that's a physics consideration. Let's just look at the base. This is going to be like an 8 down here, and this is going to be like a 5. So what's the longest distance in that base of 8 by 5? Don't tell me 8, because looky here. If I do the diagonal, which if it's a rectangular base, that's a right angle. If I do a diagonal, then that's actually longer than 8, wouldn't it be? Okay, so then again, c squared is equal to a squared plus b squared. C squared is equal to 8 squared plus 5 squared. And so then if you do the math, c is equal to, what did I get? Square root of 89 exactly, or c is approximately then 9.4340. And 9 is longer than 8. Okay, but now it's not asking about that. It's actually asking about a box, not just a table, like what's the longest stick you can put on an 8 by 5 table. Well, the longest stick you can fit on there without overhang is 9.4340. But this is now inside a rectangular box, so it's now 3 dimensions. So what we have going on is we're looking for this dimension right here up in that corner, all the way down, dot, 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 dot. Oops, I didn't draw it quite right. Let me erase that. this one all the way down inside the box to that corner right there, corner to corner, which means we then get this, right triangle right here, the height and then the diagonal of the length and the width. So we already found that diagonal. Let me redraw the triangle just a little bit here. So this is going to be 3, and then this base is the one that we actually just found there. This is the square root of 89. So then I'm going to say y. What about that one right there? That's the distance from corner to corner, here to here. So then I do it twice. So then I have to say then that y squared is equal to square root of 89 squared plus 3 squared. So then y, when I do the math in the end, is the square root of 98, or approximately 9.8995. It's pretty good. Let me show you what I'm talking about. Maybe if I can get the document camera to do this. This will be a little fun. I got a box. Zoom way out. I got a box here. Okay. What I want to know is what's the longest thing that I can stick inside the box. It will actually be from corner up here to the inside corner. It would be this distance right there. Okay. Spin it around maybe so that you can see it a little bit. It'll be that distance right there. And I've marked out inside the right triangle that I need. I need to find the diagonal of the bottom, and then I need to take it by the side. But if I hold my finger right here and I get this length, look how much longer that is than the length of the box, and certainly longer than the width of the box, and certainly longer than the height of the box. It's quite a bit higher. Alrighty? That's a great question. All right, it's a long lesson. Maybe you could do this in 2 parts. I don't know, but it's good. The Pythagorean theorem is one of those things that's got some good history behind it. There's some fantastic stories about that, like the guy that used the Pythagorean theorem to show that the Pythagorean philosophy had a flaw in it. You should read up on how they accepted him. But in any case, why does the physical world obey mathematics? And how is it possible that humans can have access to both the physical world and also the world of abstract mathematics through our minds, and can see the connection there between those, and can use it and put it to a good purpose? I think it's fantastic. Anyway, I hope you learned something, and let us pursue goodness, truth, and beauty.